They say that space is expanding, but some may find this hard to believe. Why? We'll say you measured the distance between the Earth and Mars at an instant with a very long ruler, and found it to be around 225 million meters. Exactly 10 years later, you measure this distance again and expect to get a greater reading because of the expansion of space. But since both the ruler and the length of space being measured have stretched by the same fraction, you find the length to be the same as before. So some may think that because the distance being measured and the measuring instrument will both increase over time by the same fraction, it's impossible to tell whether or not space is expanding. So how do we know that space is expanding? Well, first let's consider the Doppler effect, an apparent change in wavelength due to relative motion between a source and observer. This causes redshift if the source and or observer move away from each other, because the time taken for the observer to encounter two successive points on the wave that are in phase will increase. So the apparent wavelength will increase from the perspective of the observer. Here is the formula which relates the apparent frequency of the wave, f, to the speed of the wave, c, relative motion between the source and observer, u, and actual frequency of the wave, f0. Next, let's consider stars' absorption spectra. All stars are surrounded by a low-density atmosphere made up of the same elements that it consists of, and the electrons in those atoms are elevated to higher energy states when photons over certain energies are absorbed from the star's surface. When an absorbed photon's energy is exactly the difference between two orbitals, there is no excess energy once the electron has been elevated to a high energy orbital, so no photon of excess energy is emitted. These wavelengths of light don't penetrate the star's low-density atmosphere and define its absorption spectra, which can easily be used to calculate its redshift. The existence of redshift implies relative motion between the Earth and stars. Edwin Hubble discovered that the light emitted from stars in all directions is redshifted, which suggests that the distance between the Earth and any given point in space is increasing with time, i.e. the universe is expanding. However, the universe is expanding because the space that matter is in is itself stretching, and there is only a measurable increase in length over a sufficiently large scale.